So first thing we need to do, if we're going to find the real zeros of 2x cubed plus 11x squared minus 7x minus 6. Talk to me about some tools that we can use to begin to determine this. Yes, sir. Descartes' rule of signs. That'll tell me about positive, negative, non-real, so that I know exactly how many options I'm after. So let's look at the possible number of positive real zeros. I'm looking for sign changes. How many times do we change sign? Just once, right here. So there is only one possible positive real zero. Then for the negatives, we're going to substitute negative x in the place of x. So I have 2 times negative x cubed plus 11 times negative x squared minus 7 times negative x minus 6. How would this simplify now? 2 times negative x to the third power would simplify to what? Negative 2x cubed. What about 11 times negative x squared? It's going to stay positive 11x squared. It's going to stay positive like it was before. Negative 7 times negative x, that's going to change to plus x. And then minus 6 just comes straight down. How many times are we changing sign now? Once here and another time here. So there could be 2 negative real zeros, or there could be what? There could be no negative real zeros. There has to be one positive real zero. When we get a 1 for either the positives or negatives, we are guaranteed that 1, no more, no less. Then we've got our non-reals, and we know the degree of the entire function is what? 3. So if there's 1 positive, 2 negative, how many non-real could we have? 0. If there's 1 positive and no negative, we could have 2 non-reals. So we've got 2 possible arrangements here. All right, so I know for a fact now that there's at least 1 positive real zero. How can I begin coming up with numbers that I could use with synthetic division to do some guess and check with? Rational zero theorem. So rational zero theorem is plus or minus p over plus or minus q. Where p is all of the factors of what? Of the constant. Our constant here is negative 6. So I need all of the factors of p. So what are all of the things that you know of that'll go into 6?
1, 2, 3.
Yep, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then when we say Q, we are looking at all of the factors of what? Leading coefficient. So here's where we're looking for Q. All of the factors of Q. Since Q is 2, we've got plus or minus 1, plus or minus 2. So when I'm thinking about my rational zero theorem, initially it looks like I'm going to have to try how many options? I have how many p's? Technically 8. I'm looking at them in pairs though, so I've got plus and minus on this, but yes. Over each of my potential denominators, So I know plus or minus 1 over 1, 2 over 1, 3 over 1, and 6 over 1. And then I put it over my second denominator. Do I need to grab every single one of these? No. Plus or minus 1 over 2, I definitely need to grab. I don't already have that in the list. But plus or minus 2 over 2, I've already got that one right here because it's going to reduce down to 1. So I don't need to worry about that one. What about 3 over 2? I need that one. And 6 over 2? I don't need that one. That's a repeat also. So these are the things that I'm going to need to try. So I've got it down to a list of plus minus 1, 2, 3, 6, 1/2, and 3/2. If I ask you to list out all of the possible real zeros, this is the type of list I would be looking for. Fully simplified and no repeats on your list. So from here, what would I want to try then? Just start knocking them out. We have to pick one to start with. I usually like synthetic division because it's really, really quick and it doesn't take up as much space on my paper. We know that it has to have a positive real zero, so I'm going to try some positives first. Which one do you guys want to start with? Sounds good. I like starting with 1. It's easy. Okay, so we're going to try 1. My coefficients are 2, 11, -7, and -6. I know my remainder is going to be over here. Drop that first number down. Multiply these two together. 1 times 2 gives me 2, and then I add. So I have 13. 1 times 13 gives me 13. -7 plus 13. 6. That makes me happy. Why? I'm going to get a 0 over here. So this is the positive real 0 of f of x. So now I can write this down in a factored form. X minus 1 would be a factor. What would the other factor be? What would the quadratic factor be? Yes, 2x squared plus 13x plus 6, coming to us courtesy of the coefficients that were dropped down as part of our synthetic division. All right. So what can I do with this now to find out if there are 2 negative real zeros or if there's 2 non-real zeros? What can I do with this guy? Because I already know that this one has a 0 of 1. I can factor this. Or I can at least attempt to factor this, right? All right, so as I think about doing factoring here, we need to multiply a and c together. My a term is 2, my c term is 6. So I need 2 numbers that are going to multiply together to give me 12, but add up to my b term of 13. 12 and 1. So this will factor. So does that mean that my 2 negatives are -12 and -1? No, I do not have a leading coefficient of 1, so I cannot take that shortcut. So I'm going to do some grouping, or you're welcome to do an area model. So 2x squared plus 12x plus 1x plus 6. Make my 2 groups. I see that I can take a 2x out of both of these. And that would leave me with x plus 6. I can only take a positive 1 out of my second group, and that would leave me with x plus 6. So in factored form, I have 2x plus 1 times x plus 6. There's my function f of x fully factored. And so now I can write down my zeros. What are the zeros for this function? 1, negative 1/2, and negative 6. Were those negative zeros on the list that we came up with? Yes, they were. Let's look at another example. We're going to find the real zeros for f of x. Let's start with Descartes' rule of signs. That's a little less intimidating. Possible number of positive real zeros. 2. I have a sign change here. I have another sign change here. So there is possibly 2 positive real zeros, or there could be none. Then to find the number of potential negative real zeros, I'm going to substitute negative x in the place of x. 54 times negative x to the 4th minus 57 times negative x to the 3rd minus 323 times negative x squared plus 20 times negative x plus 12. On my first term up here, will my sign be the same as the original, or will it change? Same. It's going to stay 54 x to the 4th. What about my next term over? That one will change. This is going to be plus 57x cubed. Stay the same or change? Stays the same because I have negative x squared, so it's going to stay exactly what it was before. This is going to stay minus 323x squared. And then I'm going to have minus 20x plus 12. How many possible negative real zeros could we be looking for?
3.
See a sign change here. I see a sign change here. Where's our other sign change? I don't see one either. I just see the 2, right? This is why I actually go in and draw those little things, because at first glance, I might get it wrong. If I draw those in whenever I see a sign change, I'm more likely to count it correctly. So it could be 2 positives and 2 negatives. It could be no positives and 2 negatives. Or it could be 2 positives and no negatives. What's our other option? 0 positives, 0 negatives. Yep. And then we want to look at all of our non-real options that goes with each of these. We have a degree of what?
4.
Degree of 4. So I know that each of these has to add to 4. If I have 2 positives and 2 negatives, I have 0 non-reals. No positives and 2 negatives? 2 non-real. 2 positives, no negatives. 2 non-real. And if I don't have any real roots? 4. Yes, ma'am.
Is it any time you have two or more negatives changes, you have to like double the positives?
So if I say I have 2 or 0 positives, and then I say I have 2 or 0 negatives, it's very similar to when we're looking at this, where I have to take each of these and match it with this, each of these and match it with this, so that I can make those fractions. In this case, I'm not making fractions, but I'm taking each of these could pair with this, each of these could pair with this. So if there was a third option, then I would need 6 columns, because I have 2 options here that have to pair with each of my options for my negatives. Does that help? Yes. Okay. So I know possible positives, possible negatives. It's time for some P and Q so that we have a good idea of what types of numbers to begin trying. So I need factors of P. What is P? 12. 12 has a lot of factors. Tell me everything you know of that goes into 12. 1, 2, 3, 4, 6, and 12. So plus or minus on all of those. And then we want our factors of Q. What is Q? Yeah, we've got 54 up here. So we have quite a number of these here. 1, 2, 3, 6, 9, 18, 27, and 54. So possible rational real zeros. For time purposes, does it make sense for me to make an exhaustive list here?
No.
No. But I could start getting a list going. Now, I will tell you on the quiz on Friday, I am going to ask for an exhaustive list, but not for something as long as this. Something more like this one, where we had a grand total of 12 options, 6 numbers, positives, negatives. I will ask for a complete list on Friday, but not for a P and a Q this large. So let's start making our list, though, so that I have some numbers that I can go to as we start weeding this down. What do I know could go on that list?
All the numbers for P.
Yep, all the numbers for P. So 1, 2, 3, 4, 6, 12. Is 1/2 an option? 1/2, 2 halves, that's just 1, 3 halves. 4 halves, we already have there. 6 halves, we already have there, right? 12 halves, we already have there. I've got 1/3, and we could keep going, but I think I'm going to pause there. If we find out, like if we exhaust this list and we can't find them, we'll go back and write down some more so that we have some more numbers to try. What do you guys want to look for first? Like, which number do you want to try first? 4? Okay. Let's try 4 first. So 4, and then I have 54, negative 57, negative 323, 20, and 12. We're going to bring 54 straight down. What is 4 times 54? 216. Which we're going to add to negative 57. What is 216 minus 57? $159. Then we have to do 4 times 159. 636. We're going to subtract 323 from that. I get 313. Is this likely to be a 0? You okay if we abandon it and move on? Because I'm pretty certain, looking at the remaining numbers, that this is not going to be one of my zeros. All right, what do you want to try next then? 2. Let's try 2. So I'm going to bring the 54 down. 2 times 54. 108. Negative 57 plus 108. I'm sorry, you said how much? 51. My apologies. And then I do 2 times 51. 102. Negative 323 plus 102. Negative 222. Or sorry, 221. Negative 221. Is this one going to come out?
No.
No. All right, give me something else to try.
3.
3. All right. Let's try 3. Bring 54 down. 54 times 3. 162. 162. Take away 57. 105. 105 times 3. 315. So I have negative 323 plus 315. Negative 8. 3 times negative 8. Negative 24. Well, that leaves me with negative 4. 3 times negative 4. Negative 12. Finally, we found a 0. All right, so 3 is a positive 0. So now I know that f of x could be written as x minus 3, 54x cubed plus 105x squared minus 8x minus 4. What could I do then for this guy? I can't use quadratic factoring for that because it's a cubic. So how can I approach that? We could try some factoring by grouping. Let's see if that'll work. So I would have 54x cubed. Give myself some more room. Plus 105x squared minus 8x minus 4. If I make my groups here, I see I can take an x squared out. What else will go into both of those? What can go into both of those? Can 54 go into both of those? No. Let's look at the second group, because that'll give me some idea of kind of what I'm after, right? What can I take out of the two things in the second group? I can take a negative 4 out. That would leave me with 2x plus 1. Is there any way I can do that with those first two terms? No. All right, so new plan. What's a new plan that we could try? Well, how did we get to where we are? We did Descartes' rule of signs. We used our rational zero theorem. We tried some things, right? So if I look at like a new P and a new Q, I've got plus or minus 1, 2, and 4, right? And my Q didn't change. So I'm not going to write all those down because I already wrote them all down before. So what are some things that we could try?
Synthetic division again.
We can try some synthetic division again. I have 4 on the list, but if 4 didn't divide my original polynomial, it's not going to divide this one. We tried 2, that's on this list, but that didn't work before. 3 worked. Should we try 1 or negative 1?
Yes.
Sure. Let's see. If I try 1, 54, 105, negative 8, negative 4. Bring the 54 straight down. I have 54 plus 105. That's going to be 159. I'm leaning towards no on this one. What do you guys think?
That's not gonna work.
Yeah, 1 times 159. There's no way I'm going to get that to cancel out to be a 0 at the end. Should we try negative 1?
Yes.
Let's try negative 1. Bring 54 down. So now I'd have negative 54. What's 105 minus 54? 51. That's going to give me a negative 51 here. That's not going to work. So these two didn't work. I tried positive and negative 1. We already tried positive 2. Have we tried negative 2 yet? Let's try it. So I'm going to bring the 54 down. Negative 2 times 54.
Negative 108.
Negative 108. When I add those together, I get what?
Negative 3.
Negative 3. Negative 2 times negative 3 gives me
Negative 6.
positive 6, right?
Yes.
And then I add those two together.
Negative 2.
I get negative 2. Got another 0. Now that I have those two, do I have enough information that I can use some quadratic stuff?
Yes.
Yes. Because what I know now, let me shrink some of this stuff down so that I actually have room. I now know that I can write f of x as x minus 3 times x plus 2, and then I have this quadratic factor of 54x squared minus 3x minus 2. Still not a big fan of that leading coefficient, but at least now I have something quadratic. And if all else fails, what works every time for quadratics? Quadratic formula has to work. Take a minute or so. I want you guys to find the other two zeros here. I know I've got a 0 at 3. I know I've got a 0 at negative 2. I would like you to find the remaining two zeros using factoring, quadratic formula, whatever method you choose for that quadratic factor there. I believe that is correct. Let me double check that one real quick. I know that one's correct. Yep, absolutely right. Anybody have the remaining two zeros? Positive 2 over 9 and negative 1/6. Since those are rational, I know you managed to get this to factor. What were your factors there? Sorry, what'd you say? 9x minus 2. 6x plus 1 is how that one factors. I want to put one more problem up, and I want you guys to take this one start to finish. And I'll put the answer up after you guys have had some time to work on it, okay? I am not promising that all of the zeros for this next one are real. It does have at least one real zero. So figure out how many you're looking for. And here in about 7-8 minutes, I'll put my answer up. Give me just 1 second. All right, my answer is up on the screen. Yep, you got it. What I didn't put up was all the other guesses and checks that I had in between. Those are the ones that I found that worked.